Hello there! In today's video we are going to create and configure I/O modules, also known as input and output modules, so stay tuned. So welcome back folks to RTF. I'm Roberto Cruz, and in today's video we are going to work with the I/O configuration on Studio 5000 Logix Designer. So just a quick recap. So as we go along with the Studio 5000 Logix Designer playlist, so on our previous videos, previous two videos, right? We're going through the quick start steps. So just to some of the basics, which obviously summarize some of the basics to get you going to a simple application, right? So this is the first chapter on the help file. And it just summarizes, some of the basic steps so you can get yourself moving easily once you're creating a new application in Studio 5000 Logix Designer. So a quick recap again. So we went through on how to create a new project, as well as on how to set some of the basic settings on your Logix processor. And in today's video, we're going to be working with I/O. So basically, let's just assume you've already configured your processor, your CPU, and you set up the basic settings for it. And now we are going to add up new modules, so new I/O modules. So I'm going to show you guys how you can get yourself around the I/O configuration tab. All right, let me just switch screen so we can go through that. All right, here we go, guys. So this is the the application we've created initially. So we've created an application called Studio 5K _RTFM _revision 1, right? So I always, as for good practices, always like name my applications, and always, although some of the softwares obviously give you the capabilities so you can, work with revision control, I can always, name, by naming convention, name it with revision dates, it's obviously whatever suits you better, guys, just to get yourself familiar to backups and, the best way. Companies have their own way of, dealing with naming convention, but I always like to, for good practices, name my applications, as Rev1, Rev2, and so on and so forth. We can talk about these like in the future, right? For good practices, as a control system engineering, all right? Okay, so I've got these applications online here, guys. So obviously we configure. Let me just bring up the emulate, so these we got Logix emulate running here. So processor is running on slot 3. So and it's obviously online. There's nothing in it. So I've by the way, guys, I've created these I/O, the simulator I/O module, because I wanted to show you guys. Obviously, there's a some way of configuring our I/O modules quicker, right? And this is the reason I've created these modules on slot number 7. We'll revisit that in a second, all right? So we are online, and today we're going to talk about, so if we just bring it up here, the controller organizer. So today's video, we are working on I/O configuration tab. So here we go. So we got our chassis A7 with 7 slots. So 1756 backplane, 1756 A7. So how do you normally add a new module? So there are obviously various ways of doing it. First thing first, so we can always right-click right onto the backplane. And so you can see that the new module is grayed out. So why is it grayed out? It's grayed out because you are online. So you are unable to add up new modules whilst your application is online. So just obviously bear that in mind. So you have to be offline to create new I/O modules, right? But just revisiting the reason I've created a new module into our emulate chassis is because I wanted to show you these, guys. So let's just imagine that you have a chassis full of modules, right? So you got like 10 chassis, with 10 modules, and you wanted to configure them quicker. So instead of just picking new modules through the I/O configuration tool, you can just discover, there's a discover module. So if you push that, right, it brings up this window pop-up with select your module. So you can see now here that I have an emulator a processor on slot number 2, right? So because this has not been configured yet, it's a controller fitted on slot number 2, as well as the I/O module. So you can see it picked up them two up. So in effect, any module that sits on the your chassis, your discovery module is going to highlight that, right? So this is pretty handy. So if it would save you time if are online, you can discover them all, right? So the trouble is here is, because obviously the simulate the 1789 sim I/O module, it doesn't actually have a profile. It comes up with a question mark. So this is normally, you have to use a generic module so to be able to set up all the instances. And so this requires you to do that manually. So I've done a whole playlist on Studio 5000 Logix Emulate. So I'm gonna place a card here on these videos so you can guys access it quicker, where you can configure the I/O module. I'm actually gonna find the actual video, which shows you guys how to configure this. All right. So, and I'm gonna leave the card so for you, for your reference, so you can revisit that. So go there and watch these, videos. So it's going to show you guys how to configure that. So, right. Having said that and moving along, so this is how you do this automatically by basically scanning your whole chassis and picking up any new module, right? Existing module. Okay, lovely. So now how do we do this manually? So if you want to do this manually, so let's just say that you're going to configure, your application, but you actually don't have the hardware yet. So you can actually configure all your hardware beforehand, before you begin test benching it, or before you begin commissioning it, before any FAT or SAT, right? So how do you do this? First thing first, we switch our processor to offline. So now we've got our projects is offline, and we expand that. Let me just ping this, right? Ping that up. So, and then next step is you right click, right? If you right click here on your backplane and new module. So you bring the window pop up. I'm just gonna drag it up a little bit here so you guys will be able to see it. Here we go, guys. There it is. All the available modules that can sit on within the you can install and configure on your Studio Logix Designer are among those modules. So you've got special modules, you've got all the Allen Bradley, Rockwell automation, as well as some third parties and partners of Rockwell are sitting in here. So you can find them all in here, right? So nice and easy. You've got some of the ProSoft cards, Profibus. So you've got all the special modules and everything, right? So first thing, so you can either type, for instance, your 1756, let's just say an IB card, which is one of the digital, right? So you're one of the digital inputs. So let's say, so you got IB16, so you got your filters. So you can, by typing the right name, you could just filter them up and then select, the card that suits your application. So you can see you've got 6 types of IBs. For instance, like let's just say an IF, which is an analog card. So this is all your analog cards. So you've got various types of IF. So 16s, IF6, IF8s. So you've got various types, and obviously the vendor right here, right? So this is one way you can add the cards up. There's another way, which is show filter. So basically, you highlighted this, you've actually expanded this up, and then you can just unselect them all, right? Unselect them all. You can also now, let me just leave all the vendors. So let's just, for instance, I wanted to have a communication card. So let's just say I want an Ethernet card. So let's just pick up here the EN2T, right? Which is your Ethernet card, for instance, one of the Ethernet types. Or you want one with the obviously ring feature. So this is another one. So now I wanted to add, for instance, an analog card. Actually, let's just pick up a digital output card. So for instance, an OB. Here we go, OB16. You see? So you can then, how do you do it? Let's just select one of those here, right? I'm going to select a OB16i. So here we go. I select it and I create. Here we go. So it brings up a whole new window pop-up. So how do we do here? So these, what should we set here? So first thing, you have to select the name. So you have to name it. So let's just name these as a digital underscore output card 1. Just for the argument's sake, right? We got a couple of changes here, guys, right? So you can select the revision, firmware revision, electronic key. So you can select your electronic key. Basically, is a a special feature, right? Which gives you the capability of configuring for safety, right? So you can select an exact match. So basically, your firmware, your audio revision needs to be exact as per your selection, right? We're gonna go through these a bit deeper in the future, right? Once we talk about some of the advanced settings, all right? Okay, so let's just ignore this for the time being. So digital output, so connection, so you can set up, the RPI, so the requested pack interval. So I always leave that as a default, unless you've got a special application. But again, we're going to revisit this in the future to be a bit more, to dive into this a bit more deeper, all right, in the near future, right? So you've got some module info. This is obviously available once you are online with your application. Configuration, so you've got some special configuration. So configuration depends on the module itself. So some of the modules might have more, configuration. Like for instance, an analog input card should allow you to do a couple of scaling settings, some basics. So this is obviously gives you some fault capabilities, right? So you can have some statuses, for instance. So like you can select, what happens to a certain output in case a fault occurred. For instance, you can turn it off, you can keep it on, you can hold it. So there are various things, but we're gonna revisit that, in the near future, right? So for the meantime, let's just leave with digital output 1, for instance. And as soon as we create, let me just close this, and here we go. You see, so this is now, I forgot to mention that, but let's just double click. So important one, obviously your card, you need to actually point to which slot your module, your card or module, whichever way. It's, there are people who call them modules, there are people who call them cards, IO cards, doesn't matter, they are all the same. So this is being fitted on slot number 0, right? So again, let's just do one more now. So instead of, let me just close the screen, push OK, right. So again, so we right click, there's another way of doing things quicker. So let's just say you are just developing and, your company is familiar to a certain module. So you always use the same module. So what you can do is, once you select a certain module, you can add them to favorites. So you can favorites them, right? So you've got your favorites tab, and here we go. So all the modules that you use most, because you've got dozens of modules, right? So to simplify, make your life easy, you can always add them to your favorites tab. So let's just, as we've added an output card, let's just add now an analog input, right? So let's just say an IF8, which is basically an 8-channel, no isolated voltage current analog input. So you select this, push create button, it's gonna bring up again another window right over here. So we name this as analog, let's just AN, analog AN1, let's just say, and this is going to be on slot 5, right? You can add a few descriptions here. Module definition, we're gonna go through this, in the future. You remember when I said to you about the configuration? So you see there is some special configurations when you select an iOS. So you can set up the RTS. There are some module filtering here, so some different frequencies. When you select the channel, you can select by either voltage or current, depends on your application, your wiring. Once we are obviously making a playlist on IO modules, so I'm gonna show you guys all the wiring, all the wiring available for a certain module, right? So you see there are various settings, right? So you can actually scaling them. So like engineering units, so you can have percentage, liters per second. So you can have whichever, engineering unit is most suitable to your application, you can configure here. So your high signal, for instance, your high training. Let's just say you select here, for example, 0 milliamp to 20 milliamps. So your high sig is going to be equal to 100%, and your 0 is going to be equal to 0%. You see, so it's some special, you know, obviously you can always set your high and high, your alarm bands. You see, so your process alarming. So this is pretty, you know, powerful. You can do so much with these, you know, cards. They're great. So we're not gonna mess around with these right now, and we'll just push OK to be able to add them cards. And here we go. Lovely. So we've had those two cards, and just before we finish this video, right? So let me just show you guys how you can access them, and obviously memory, right? In the actual memory. So take a look at this. So basically, we've added on slot number 0 our digital output. So it had, as soon as you added it, it has created those 3 instances, right? So you've got one local, basically is obviously referring to your local chassis, and C is basically all your status, your controller status, your I/O status. You've got also some status in, you know, in the I/O, in the high definition, as well as on, oh, this is the actual output. So those are the addresses that you're going to be driving. If you have, for instance, you know, a motor or a valve, so this is where your wiring is going to be wiring to into the, this is the actual memory that you're going to be using to drive, you know, the output, the internal transistor, which is going to drive the output. So basically, on your I definition is where I can't remember what this C stands for, but like I said, we're going to be a bit more specific in the near future. But basically, you can see that this is where you can manipulate some configurations. So so you can, for instance, if we just expand that, so this is where you can actually write down some configuration so that your module can act differently, right, based on your configuration. So you see that fault mode, fault value, program mode, program value. So this is where once we are RTFMing this particularly module, we're going to unfold and obviously explain all those bits, all right? Your I, right, your 0I, local 0I, stands for statuses. So this is where you monitor the state. So whether a module is in a state of fault, right? So this is where you monitor them. So basically, for instance, data 0 is your output 0. The same is going to apply to fault 0. So if there is a fault on your first output, it's going to flag up here, right? Like a hardware fault, for instance. So the same applies to your analog card. So basically, if we expand that, you see we got channels. So basically 6 channels starting from 0. So you've got channel 0, 1, 2. Oh, sorry, this is actually yeah, this is a 4 channel actually, isn't it? And then you've got some statuses, and the same applies to the C instances where you can configure, right? So you can configure your cards. You see, remember those alarm settings, so you can actually manipulate them here on these tabular, you know, type. So we're going to revisit this tabular type, which is very handy for you to be able to handle your not only your tags, your I/O tags, but your memories as well, right? All the tags that you're going to be using in your application. All right, guys, so this is it for today. So actually, this is one of the longest, right? So almost 20 minutes. So thanks for watching, guys. So this is we just showed you guys how you can quickly add up new modules to your application. So I hope you guys find these very useful, very handy, right? So this is we're still gonna go through various steps on quick start steps. So yeah, so thanks again for watching, guys. If you do like the content, please consider subscribing to our channel. Likes are, you know, very much appreciated. So stay with me, stay tuned. Make sure you ring the bell to get notified of our latest videos. And as I always remind you guys, always RTFM, and I'll see you guys next time.